Hey there, and welcome. Have you ever really thought about that strange, invisible force that makes a magnet snap to your fridge? Or how a compass needle just knows which way is north? Well, today, we're going to pull back the curtain on the secret that powers literally every magnet in the universe.
Right? I mean, think about it. You can have a simple compass, and no matter how you twist it or turn it, that little needle fights to point north. So what is that? Where does that insistent, invisible push and pull really come from? Let's find out.
To get to the bottom of it, we have to go small. And I mean really, really small. We're talking about shrinking down past the metal itself, past the molecules, and diving right into the quantum world of the atom. Because that, my friends, is where the real story begins.
So here's how we're going to tackle this. First, we'll nail down the key concept here, something called the magnetic moment. Then we're going to trace it all the way back to where it starts, inside the atom. We'll see how that helps us classify different materials, and then we'll check out the amazing real-world tech this all makes possible.
Okay, so first things first. If we really want to get a grip on magnetism, there's one key idea we absolutely have to understand. Physicists call it the magnetic moment. So, what on earth is it? Well, in simple terms, the magnetic moment is a measure of two things: a magnet's strength and its orientation. Now, the super important word here is vector. That means it's not just a number telling you how strong the magnet is, it also has a direction. It's pointing somewhere very specific in space.
Think of it like an arrow. This arrow, the magnetic moment, points from the magnet's south pole to its north pole. This is what gives an object its own magnetic field, and this is the crucial part. It's why that object will always try to line up with any other magnetic field it finds itself in. That's exactly what our compass needle is doing.
So we know what a magnetic moment is, but where does it come from? How is it created? Well, for that, we have to go back down to the atomic level and zoom in on one tiny particle in particular, the electron.
It turns out there are two main things an electron does to create this magnetic moment. First, you have what's called spin. You can kind of picture the electron as a tiny spinning top, and that constant rotation, that's a fundamental property it has, generates its own little magnetic field. But that's not all. Second, there's its orbital motion. As the electron zips around the atom's nucleus, it's basically creating a tiny circular electric current. And as you might know, any electric current creates a magnetic field.
So, here's the key takeaway. Every single atom gets its total magnetic moment from adding up all the tiny spin and orbital moments of all its electrons. This is why different elements, like iron versus copper, have completely different magnetic signatures. It's all in their electron setup.
Okay, let's zoom back out to the big picture. We know how one atom gets its magnetism, but what happens when you have trillions and trillions of these atoms all packed together in a piece of metal? Well, how they all interact with each other is what gives a material its overall magnetic personality.
It's really a game of teamwork. Are all those tiny atomic magnets pointing in random directions, basically canceling each other out? Or are they all cooperating, lining up and pointing the same way to create one giant, powerful magnetic field? This collective behavior, well, it changes everything.
And based on that teamwork, we can sort materials into a few key groups. You've got diamagnetic materials, which are actually weakly repelled by magnets. Then there are paramagnetic ones, which are just weakly attracted. The ones we all know and love are ferromagnetic materials, like iron, where all the atoms get on the same page and create a super strong attraction. And then you get these other, more complex types, like antiferromagnetic and ferromagnetic, where atoms line up in opposite directions, either canceling each other out completely or just partially.
And here's a wild fact for you. Turns out every single thing, and I mean everything, you, me, the water you're drinking, the air you're breathing, is technically diamagnetic. It's just that this repulsive effect is so incredibly faint that you'd never notice it unless all other magnetic properties are totally absent. Kinda cool, right?
Okay, so this is all really fascinating physics, but let's talk about the real world. Why does any of this matter? Well, understanding and being able to control these magnetic moments isn't just for textbooks, it is the absolute foundation of so much of our modern technology.
So how do we even measure these invisible fields? Well, scientists have a tool called a magnetometer. Some versions, the vector ones, are really sophisticated and can measure both the strength and the direction of the field. Others, the scalar ones, just measure the overall strength. And of course, the simplest example of all is the one we started with, a good old-fashioned compass.
And the impact of this knowledge is just staggering. Seriously, we're talking about everything from the hard drives and SSDs that store all our digital data to the MRI machines that let doctors see inside our bodies without a single cut. It's used everywhere. Geophysics to study the Earth, archaeology to find buried ruins, even in finding oil and gas.
So if there's one thing to take away from all this, it's that entire journey, from the quantum spin of one tiny electron, all the way up to the global technologies that define our age, is all tied together by this one fundamental concept, the magnetic moment. It is truly one of the invisible forces that shapes our reality.
It really gets you thinking, doesn't it? We just unpacked this one incredible, invisible force that organizes our universe, from the tiniest scales to the largest. What other unseen rules and hidden forces are out there, quietly shaping the world we see and experience every single day? Thank you so much for coming along on this deep dive into the heart of a magnet. I really hope this gave you a whole new appreciation for the powerful, invisible world that's all around us. Until next time, stay curious.